Great, let's get started. So, like I said, we're here from ITRS Group. So we've been a financial monitoring company, and we've just opened up in Malaga, and I'm really excited because this is the first time we're going to be showing off Velo. And Velo is the new technology that we're building to power the next generation of products, not only in financial monitoring, but also across various different spaces. But the really interesting thing is, I'm going to be doing some live demonstrations, but at the same time, what I really want to focus on is the capability of Velo and what happens when you take the sort of complex analytics that we've been looking at today and make it easy to reuse in various different situations. So because we're a financial monitoring company, let's say I work in a bank, for example, and banks naturally have big, complicated trading systems, and they're very hideous organic beasts often. They've been built up over time. They're made from various different components, some of them made in-house, some of them cobbled together. And one of the most important things people try and find out is what's the latency of an order? If I've got trades coming in and trades leaving out because they've been matched, how can we calculate the latency of this order? This is an incredible challenge. So to get started with, what you need to do is you need to publish data into Velo. In common with so many of the things that we've spoken about today, Velo is a cluster of nodes, and the API for publishing data into Velo is incredibly simple. Structure it in a JSON document and issue HTTP posts to the system, and then we can start analyzing it. So in this case, we've got the sending time of some orders, and we've got the message direction coming in, we've got the message direction coming out. And so this example I'll be showing you is from actual real trading data. Fixed data is the technical term for it. So here's a key interesting thing that you need to know up front in order to start using Velo. You need to tell Velo the schema of your data, because this is really important to the optimizations that we're able to do later on. Again, it's relatively easy. You just format schema saying, OK, we've got a field that's a string, we've got some fields that's date time. And so in combination with telling Velo the schema and starting to publish the data, then we can start doing some analysis. So here's a big, scary query that is going to be performing this analysis for us. But because I'm here in Big Data Spain, I don't think it should be too bad. So we've got the idea of streams. When we publish data into Velo, we're publishing it along streams. In this case, we've just given it a name, streams, demo, fix, exchange. So I'm taking the stream and filtering on the input messages that are coming in, where the message direction is input. And then I'm joining it on the same stream, but filtered by the output messages. Then I'm joining on the criteria where the order IDs are the same, and then also a bit of cleanup just due to the data. And then the key point here is that I'm selecting the difference between the sending time of the input messages and the sending time of the output messages. And this is where things get interesting. You query Velo with a SQL-like language that we've built, but what it's actually mapping to is much more of an analytical pipeline. So I'm able to do interesting things like multiple selects here. I've done the first select in order to do my calculation, and then I'm doing the second select just to extract the milliseconds of latency from what we're doing. So this is probably the biggest screen anyone's put IntelliJ on, so enjoy it while you can see it. The first thing I'm going to do is I'm just going to start up Velo, and then I'm going to start up an instance of Logstash. And this instance of Logstash is just publishing that trading data that we were talking about. So I'll start it up. And it'll run, and Logstash, because it's based on JRuby, will have a think about starting up. This is what happens when you do big data demos on a ThinkPad. Everything has to wait for a little bit. But once that starts publishing the information, fantastic. So we've got the query interface you're seeing here. We're still working on, and it's in progress. It's based on the concept of notebooks that everyone's very familiar with IPython and Jupyter and the other things you've seen. So I'm just going to create a new notebook in order to run this query that we've got. I'm going to create a new query, and I'm just going to copy the query out of the presentation, if it will let me, and copy it in. So I'm going to run this. Note the use of from historical. So Velo is a hybrid system. It's able to work on historical and real-time data. And the really exciting stuff is when you can work on a hybrid of the two. But for the moment, we'll just run this completely historically against the data I just loaded. So we'll run it.
Michael, terribly sorry to interrupt.
Oh, it's fine.
Quite a lot of people waiting to come in, and I'd rather that you...
You know what? I'm happy to wait if everyone wants to come in. Come in. You're here for a live software demo as well. It's fantastic. The best thing is the systems normally that you have to build to construct something that's this complicated is... come again? Sorry? A recap. I'll do a recap when everyone's sat down. But just to tell people who've already been in the room, the systems you have to build, or we've tried to build in the past to do this, have been incredibly complicated. So it might be kind of hard to describe quite quickly, but for clients in the financial sector, this is incredible, that you can use this notebook style to analysis and this simple SQL-like language in order to analyze the stuff that we've just sent into Velo very simply. Man, this is getting really popular. This is awesome. Fantastic. Come on in. Fantastic. Oh, wow. Full house, I think. We're good to go? Okay. Hello, new people. You're here to learn about Velo. Velo is a new, completely new big data system designed for hybrid real-time and historical analytics. And the focus of this talk is going to be on why Velo makes it really easy to reuse the kind of complex analysis that we all do in our jobs day to day. So the example I've just been working with is an example of real trading data. And what we have is we have trades coming into a trading machine and trades coming out. And what we really want to do is to be able to calculate the latency, because this system is big and complicated. So we want to just tap it at the front, tap it at the exit point, and see the latency of the order. So, like I said, it's very easy to publish data into Velo. You do an HTTP post, and a very key point to remember, all of the advantages I'm going to describe to you later on, they all come from telling Velo the schema of your data. And this schema gets preserved all the way through the analytical pipeline. So that's a query, and this query is joining from a single stream. It's filtering on the messages coming in, and then filtering the messages coming out, and joining them together. So I was going to say, can anyone read that? And then I remembered the screen is about 18 feet tall, so it's probably quite easy to read. So we've got the ability to do joins, and the key point is here we're working on historical data from these streams of information. We're joining it together and then selecting the difference between the sending time of the input orders and the sending time of the output orders. And then we get the latencies coming through. And that's just kind of a simple example of how I was able to just use Logstash to just take the log, and it's the actual raw log coming from an actual trading machine, throw it into Velo, and start doing some analysis on it. So what's actually happening under the hood? So in common with systems like Apache Spark, what we're doing is we're taking this query and we're translating it into a computational graph. This is a particularly simplified version, so I'm going to show you what the actual computational graph looks like for what we just did. So there it is in all of its glory. We're selecting data from these from nodes, passing them through various analytical stages. There's some merges. It has to go to a single point in order to perform the join, and then we get the output into the view that I'm showing in this in our user interface here. Now, we wanted to build this sort of system because we needed, to start with, we wanted to provide this sort of analytics to our existing clients. So when we were looking at building this from scratch, we looked at all of the existing systems that were around, you know, everything you see on the screen, and all the fantastic stuff we've been talking about today. And let's say you're trying to build this with Spark. So you're running Spark, but then you're thinking of the administrative overhead. So like, okay, well, I need to run Spark, so I need to run up my cluster of nodes. And actually, these days, do I need Mesosphere to actually run Spark? And what's the management overhead of all of this? And well, maybe I need Kafka to feed it. And then, of course, I need Hadoop to store my data. But actually, it's textual data, so I want to use Elasticsearch. And before you know it, you've built a big, complicated system. This is fine. This is absolutely fine. The problem is, what happens if you want to take your big, complicated system and analyze different data? What happens if you've got completely different analytical requirements? This is where it gets very difficult at the moment in order to take the pipeline and the combination of systems you've built and reuse it. So we've got Velo. It's a cluster of nodes. To start up a cluster, you run it with a command line. They join each other. It's a Dynamo-style architecture, so there's no central point of consensus. We know where data should be stored. Each node is capable of handling all operations, and the nodes are homogeneous as well. There's no special capabilities, no special roles. Every node provides the same capabilities. And the data we work with is streams of data. The data flowing in, it's immutable, append-only, and potentially distributed across various nodes in the cluster. I'd love to talk about what happens when we handle failure of individual nodes, but I've only got 40 minutes. So if anyone wants to grab me afterwards, I'll talk about our failure handling, because it's very interesting and how it ties into the data model. But if we've acknowledged a write, it's there, and you'll see it in a historical query for sure. So in our architecture, we know, without consensus across the nodes, where the data is stored for this particular stream. So that's a great start, and that was the from nodes that we were seeing when I was showing the explain result of the query before. So now, I said we send the data into Velo. That means we have to store it in order to run that query. So how does the storage work? Well, in Velo, we deal with repositories, and we've got 2 repositories at the moment. Because we started off building a system that would make sense for us as a financial monitoring company, we knew we needed 2 things. The first is we needed what we call the semi-structured repository. This is Lucene. So in the same way Elasticsearch is built on top of Lucene, the semi-structured repository is built on top of Lucene. It has the same capabilities for faceted search, taxonomies, very fast histograms, and all the great things that you saw in the talk from the Strat.io guys earlier on. The second one we have, and this is the really interesting one, is we have a time series repository. So much of monitoring data is time series. If you look at CPU utilization over time, it's a time series, obviously. If you look at trading volume, it's a time series. So our time series repository we've built is completely custom. We've got our own I/O layer, abstracting over some of the issues that you have when you try and implement just about anything using Java and I/O. And we've also got our own B-tree indices in there. So at the moment, you can kind of think of it like Cassandra. It's a very, very big column store with good indices for doing range queries across time series. The places where this gets really exciting is when we start using these repositories, because in traditional systems, your query will get to a point, and it will, maybe if you've got your data stored in Hadoop, you'll be streaming the data out and through the analytical pipeline. But for us, we take the computational graph, and then the computational engine distributed across the cluster talks to the repositories, and it says to the repositories, here's the computation I'd like to perform. How much of it can you do without moving the data? How much of it can you execute directly against the data, and how much of it can you execute taking advantage of the indices, especially for filters or various different points. We can promote joins, for example, if the data is joined in the same place. And so this process of taking the computation graph and promoting it down to execute directly against the data is key for Velo, because for historical queries, we can get those answers faster and more efficient. And this is why having our own time series repository is so interesting, because we're now working, the 2 guys we have in Australia building the time series repository, they're working on adding time series indexing using ISACs natively into this repository. So think of the capability that you've got from fuzzy search in Lucene. We're adding that to time series as well, which I'll show you a quick demo of in a second. So I'm going to bring this back to use cases again, and how Velo is helping you reuse monitoring in surprising cases. So I work in a hospital, and we're monitoring the heart rate. Well, I don't actually work in a hospital. Imagine I worked in a hospital, and we're monitoring the heart rate of a lot of people. And what we're interested in is unusual activity in these heart rates, because obviously everyone's heart rate is different. It'll blip twice, but the frequency at which it blips is completely different. And so it's difficult to know, without sort of hard coding it in many ways, what is abnormal for someone's heartbeat. So because we're here and because we're data scientists, we search around and we find a paper. And here's an interesting paper. This is assumption-free anomaly detection and time series. So this is saying, I can tell you when your time series is abnormal, and you don't have to tell me anything up front, apart from just training it for a short amount of time. And you're thinking, this is a good paper. I mean, look, it's got aim and cough on it, so basically, it's going to be a good paper. So what normally is the process from taking the ideas you've read in a good paper and translating them into actual distributed big data analysis? It's quite hard, right? I mean, that's our jobs. So how does Velo make this easier? So I'm not going to show you the actual implementation of the nitty-gritty of this algorithm, just how the implementation integrates with Velo. So this first Scala case class that you're seeing here is the parameters for the input to the algorithm. In our case, it's the window sizes ahead and behind the analysis we're performing, but it can be any input parameters you want to your algorithm. And then we've got the result type as well. In this case, we've got the point, the actual data itself, the time series data itself, and then the signal, which we'll see later on. But that's the output of the analysis. So I've just described what's coming in and what's coming out. In Scala case classes, can't be easier than that. And then I've got this little factory here that I'm using to register the algorithm. It's got a name, and that name obviously is just how we're going to invoke it in the query later on. We've got an annotation in the schema, which I'll get to later on. And then the key things are these properties that we've got here. When you construct an algorithm and you give it to Velo, you tell us the distribution properties of this algorithm. So in this case, the algorithm I've given you is actually quite bad because it's not commutative, it's not associative, and it's not mergeable. This is saying basically the algorithm must execute completely in order across all of the time series data we're looking at. Now, of course, that's not true for everything. If you look at the implementation of simple counters and sums in Velo, then obviously they are all of those things. And so we can immediately start distributing the analysis across all of the nodes that are storing data for that stream. But one of the really big innovations we've got, and this is awesome, is we've extended it to say, OK, what windows of data are you operating on? How much data do you need to see in front of you, and how much data do you need to see behind you in your algorithm in order to do your job? Because then we can start parallelizing difficult algorithms like this. Because if this algorithm doesn't need to know anything previous to the last 40 points, for example, doesn't matter. So we can just parallelize this computation and then bring it back later on, which is awesome. So again, it's completely simple to publish the data, HTTP posts. Notice an interesting new field we've got here, this idea of contributor. So now I've got a time series, and each value that's coming in, where I'm also passing in the monitor that it came from, and Velo is remembering that later on. So let's run a query. This query is just going to say, OK, run my anomaly detection algorithm that I just wrote, and group by contributor, because if I tried to run anomaly detection on all of the time series at once, it would be a massive mess. We're only interested in running it per monitor that we're seeing in our data. So back to IntelliJ, highly professional, I know. This is simulated data, so I'm going to simulate 10 of these ECG monitors, and the ECG data we're looking at is actually from the sample data that was published with the paper that we were looking at before. So that's going to sit there, and it's going to publish some data. And I'm going to create a new notebook to run the query. And it's going to come back. And there we are. We've got the data coming through. It's still training. And did you notice the trick? That's real-time data. So the only difference, really, in the historical query and the real-time query is one of them said from historical and one of them said from. The rest of the query is completely the same. Velo does not distinguish when you submit a query in the analysis from real-time and historical. And this is really interesting because as we move forward, we want to get rid of historical in the language. And we want you to say to Velo the time range you're operating on. Get me last week until today. Get me yesterday until real time. So we are able to bootstrap computation of historical data and then start applying it on a real-time stream, which, as you can imagine, if you're creating machine learning models, is incredibly powerful. So it's doing its job. Fantastic. It's already detecting anomalous behavior in these time series. This is beta code, so I'm going to change that ever so slightly. No, you don't like me? No. Let's try 1,000. Oh, there we go. But you were able to see that it was detecting anomalies, and they were showing up as red. If I put enough points back, it should come back. No, it doesn't like me. OK, so the key point is we saw those. In fact, you know what I can do? I can bail out, and I can say, OK, the real-time one is not working for this demo, so let's run it completely historically on the data we've already published. Run. And we'll look at the anomaly detection again. There we go. So we can see the anomalies there. I wish we had a zoom function at this, but we don't. So you can see the anomalies being detected. The key point is we've got this graphing capability. And did you see that annotation we put in the factory when we were registering the algorithm? That annotation is preserved through the API all the way to the output of the query. So this is what our visualization team in Malaga is able to see and then say, OK, I know I can plot this in this anomaly detection chart, which is showing up things in red. Velo preserves the schema from storage of data all the way through the analysis pipeline, no matter how complicated it is, right through to the end result. And we can match up the parameters to what we were seeing in the code before. So I'm focusing in this talk on reuse of analysis. And so going back to a hospital situation, imagine that we have one type of ECG monitor that is consistently producing bad results and difficult results. And we want to monitor that specifically, and we don't want to look at the other monitors. But the interesting thing about these monitors is maybe they move between buildings. You know, patients move, so the monitor might move with them. We've got this kind of dynamic set of the contributors of the data. The monitor is contributing the data to Velo, and we want to create these dynamic sets of them that update so that we can change the context of our monitoring to various different things. But again, we want to reuse that analysis we created before. We don't want to have to rewrite the analytical queries just to reuse it. So imagine we've got Acme monitors. Now, this is interesting. I'm just going to have a quick check. Is it publishing Acme monitors or something else? Let's have a look. No, I used actual company names. Oops, that was a mistake. So let's create a domain. And these domains are the idea that these are going to constrain the analysis that we were looking at. So they're defined using very simple predicate filters on that contributor data, because as well as publishing the values to the streams, we're also publishing metadata about these contributors. So in my case, in this demo, we're publishing the manufacturer and the building and everything that they're appearing from. And this is data that the streams are immutable and don't change, but the current state of the contributor metadata does update, and that's what we can use to define these domains. So I will create my new domain. I've got another contributor here called probes that we're not interested in. I'll call this G monitors. And I will say manufacturer equals GE. So check my query is matching things. So now, whereas before I had 10 monitors, now I've only got 3. And I'll save that. And now everything that's happening inside this domain, we're just looking at these monitors. And now I'm going to create a new notebook, and I'm going to start running the same query we had before, but without changing it, but against the new domain. And we've got 3 results. And if new monitors were to appear and disappear in this domain, then the results would, we'd see new results appear, and the results disappear. Notice, we haven't changed the query. Admittedly, in my case, my query is actually quite simple, but you can focus on the analysis. The filtering by the particular domain is tangential to the actual definition of the analysis, and Velo is built with this workflow in mind. Because if you've defined a query, that might not be so hard to reuse. But we also just defined a complete implementation of an algorithm, which we also passed to Velo, and we don't want to have to copy that around just to reuse it in some different domains. So the last thing I'll kind of talk about, in fact, there's something I'll talk about first, which is there's one thing missing in our UI at the moment. And I showed you the code for implementing your own functions, and you can pass that in if you had access to the Velo code. What we need is we need the ability for you guys and the people using Velo to define your own functions and pass them in alongside the analysis. It needs to be we're going to add it as another panel, type of panel in your notebook. So there are some things which are very easy to express as SQL-like queries. But then, let's face it, there are other things that are much easier to implement as code. And if you look at some systems, for example, like the one Microsoft Azure released recently, if you try and combine SQL-like queries with the actual code itself, yeah, you end up with a very big query that is kind of difficult to understand. So by making this separation, I think it fits in really nicely with how your flow goes when you're trying to analyze some data. In that maybe you want to implement something just in code, maybe you want to implement, or then you want a more declarative syntax to use for your queries. So I hope this has sort of driven home in a small demo that I'm running on a ThinkPad exactly how Velo is being designed to help you reuse analysis. And I hope it's also kind of the fact that we've not got this distinction between real-time and historical, that we can bootstrap computation from historical using our repositories and taking advantage of all of the indices that we've got, and then seamlessly passing on to real-time. And then this computation is happening, and the overall management of Velo to run it is relatively simple. You just run the software. So while I was starting this presentation, I was thinking that anomaly detection is quite cool. But I spend a lot of my spare time, kind of audio programming. I'm a bit of an audio nerd. So I was thinking, what would happen if I took that anomaly detection and I just strap it to the microphone of my laptop? Would it be able to detect anomalies in the sound in the room? So again, I didn't have to change the analysis. All I wrote was a small piece of code that records from my microphone and publishes it into Velo. So let me turn that on for you and run it. And have I got the Wi-Fi? Because I'll need the... Pure awesome. So I'm going to check it started. Successfully started the microphone transport. Fantastic. So I'm going to create a new notebook here. And here's another interesting thing. This query I'm running here is going to take from the stream of microphone data. It's going to take the time now. And then, admittedly, I'll be honest, if I tried to run the anomaly detection algorithm through all 44,100 samples a second coming from the microphone on a ThinkPad, I might have some issues. So I'm just going to cheat a little bit and window it by every 100 milliseconds and take the maximum. But it will demonstrate the point. An interesting thing here is at the end, I've said, OK, create a new stream from this called mtest. So when I talked about having an immutable model of data and data just comes into streams, you're probably thinking, OK, but we live in the real world and we need to do historical data management. I don't have an infinite amount of data storage. But we realized as we were working with Velo that actually it becomes relatively easy. You can just issue a query. You can take advantage of the analytical capability we've got. Maybe you only want to store the 99th percentile every minute of the last week's worth of data. Create a query to define the 99th percentile and store it into a new stream and delete the old stuff. So historical data management in Velo is actually just more analysis and more queries. So I'm going to create the stream from here. And it's executed. And now I'm just going to run the anomaly detection function that we defined before against the microphone data coming from the laptop. Now, what I want you guys to do is clap. You know what's great? It actually thinks it's anomalous that you're not clapping, so I guess that's kind of cool. But it demonstrates the point that without changing the query and without actually having to rewrite too much, I'm reusing this algorithm against a completely different set of data, all just by without changing the definition of the algorithm and using similar queries. So I've gone through this really fast, actually. I think that's pretty much everything I was really aiming to cover, is that it's a brand new system. And the reason it's a brand new system is the advantage we get from integrating data storage. We're able to take these queries, these big graphs of queries, and push them down and run them against the actual analysis. But we've combined that with real-time processing as well, all inside one system, and then presented it from the front end you were seeing here. By the way, what you're seeing here in this interface is just being built using our APIs. So if you're looking to build something that's powered by Velo, or you're looking to integrate Velo analysis with other systems that you've got, it's just an HTTP API with server-sent events for live streaming, so it's relatively easy to use. We tried to really pare down the management overhead of running these sort of big data systems. It's a Java process, and if you provide it with good disks and good storage, that's all you need. And at the same time, we're thinking that many analytical cases, you're thinking about actually processing the data and then you're thinking about, okay, how can I reuse this, and how can I create a new domain and reuse this analysis for a subset of the data I'm interested in. So we've got this idea of domains, and they cross-cut the API. So once you create a domain, if you then apply a domain to a query, then you don't have to rewrite the query, which may be, if your query is as big and relatively complicated as that, it's not even that bad. But as it gets bigger and bigger and bigger, you don't want to have to take that apart to reuse it in various different situations. So in Velo, you can create new streams from it and then perform new derived analysis on those streams, or you can create a domain and apply it to a subset of your data. So that's a very quick introduction to the technology. What I'd really like to also talk about is how to use what sort of functions people will be interested in. So please find me afterwards and tell me what difficulties you're having trying to implement certain algorithms or machine learning methods in the tools you've got at the moment, and maybe how Velo could help, and how we can kind of move it on through the future. And we've got the website where you can register. And also, if you're interested in this sort of thing, there's the Lambda World Conference down in the south, because I've got to shout out Malaga. Velo is a product of Malaga and the great cool technology scene down there. So there's the Lambda World Conference as well. So with that, thank you very much, and any questions, please let me know.
What are the plans for Velo? Will it be a paid?
So the question is, what are the plans for Velo, and how will we essentially take it to market? That's an interesting thing. For us, the most important thing now is to prove the technology. We're proving the technology with our existing clients, and so we're interested in collaborating with people at the moment to prove the technology, and so that needs to be developed over time. And certainly, once it gets to a point where we've collaborated with people and we've done more than prove the technology, we're wanting to actually build something, production on it, then those questions will be answered. But at the moment, it's something we're working out at the same time as proving the technology. Go for it. No, so you can select which repository you're sending the data to, and that's a really good point. So as well as defining the schema of the data, you also need to have some upfront thinking about which repository would be most valid and would provide you the most useful speed up, and the indices would be the correct ones for the data you're passing in. So if you're passing in JSON-style data that you want to do Lucene, fuzzy text searching, or similar things, then the semi-structured repository is your choice. If you've got data which is, think about, you can plot it on a line graph. If it's a lot of timestamps and values, multiple values potentially, but linear time series style data, then you want to pick the time series repository. An interesting thing that we're working on at the moment is how Velo can help you construct the schema from unstructured data, because of course we're built on top of Lucene, so you can throw unstructured data at Lucene and the default analyzers will do a reasonable job of indexing. So an interesting part of this collaboration would be to work on, okay, how can Velo help you construct the schema of the data? But up front, you tell us the schema of the data and which repository you want to use.